In this podcast, we'll go over what ionic bonding is and what that means for compounds. All right, first and foremost, we are talking about ionic bonding. So ionic bonding results in ionic compounds. And ionic compounds are formed between a metal and a nonmetal. You have to have those two components. The nonmetal and the metal are chemically combined, and in an ionic bond, we transfer the electrons from the metal to the nonmetal, and it always goes in that direction. Our metals can be one of two types. They can either be representative metals, which are your group A metals, or they can be transition metals, which are your group B metals. Okay, so either way, it's still ionic bonding. They're both metals. The difference will be in how we name and write them later. Not our problem now, it's future use problem. If it is a representative metal, so we're talking about group 1, group 2, and a couple of others on the other side, they will always have a single charge. So for example, magnesium is always a 2+ charge. It only has a single charge. It's when we get into our group B metals that it gets a little bit challenging. Your transition metals have multiple charges. For example, iron, which is in group B, your transition metals, can either be a +2 charge or a +3 charge, but they're both still metals and they're both used in ionic bonding. So this periodic table just gives us an idea of what all the charges are. It would be absolutely positively insane for you to memorize every single one of these. But I do want to point out some patterns that we see in the periodic table. For example, all of group 1 are going to have a +1 charge. Okay, all of your group 2 have a +2 charge. These are your representative or your group A metals. Okay, there are some metals, some nonmetals, and some metalloids in here, but group 3 will be group 3A will be a +3 charge. And then the rest of these shown are nonmetals, and those charges would be kind of important. If you go down, they're for the most part all -3, -2, -1 charge. So where it gets kind of dicey is right in here. I'm going to do a different color. Is your group B, your transition metals. So that's this entire area right here. Group B, your transition metals, almost all of them are going to have multiple charges. And I just want to highlight a couple of these right here. Like, for example, nickel is +2 or +3. Copper is +1 or +2. And so it's not necessary for you to memorize this. We'll talk about how to figure out whether you're dealing with a +1 copper or a +2 copper later on. Just know that they don't have a set number. The ones I want to draw your attention to that you should probably have memorized, they are exceptions to this rule. That is zinc, which always has a +2 charge, silver, which always has a +1, and cadmium, which always has a +2. We don't use cadmium much, but those are just good to kind of have in your back pocket to know. What makes an ionic bond unique is the transfer of electrons. So that's the big idea. In covalent bonds, we don't see that same transfer of electrons, but we do in an ionic bond because we're dealing with a metal and a nonmetal. So atom 1 is our metal, and metals always transfer their electrons to the nonmetals. So we see an electron, this cute little red dot, floating around in the electron cloud for element A. Because it's a metal, that electron gets transferred to element B. When element A loses an electron, now it has one more proton than electron, so it has a +1 charge. Atom B has gained an additional electron, so it has one more electron than proton, so it has a -1 charge. So it is actually these charges that are holding these two elements together, and that's an incredibly strong bond. Think of that like two magnets, the north and the south end, so they're opposite charges, and they're super attractive, and they're holding them super tight together. If we had two electrons on A, we would transfer them both to B, and this would be a 2+ charge or a 2- charge on atom B. So just kind of think about the transfer of electrons as being something unique for ionic bonds, and that both representative metals with a single charge and transition metals with multiple charges both will go through this transfer of electrons.